Hi, this is JD, and in this lecture we're going to look at operations with radicals, including expressions and solving radical equations.
So this is a continuation of last week. We looked at radicals and introduced square roots and cube roots. Today we're going to take that a little further, and we're going to look at radical expressions and radical equations. Radical expressions. So here are the basic rules of radicals. Now, when it's the square root of a squared, see there is the absolute value of a, but if you know that all the numbers are non-negative numbers or all positive numbers, then you don't really need the absolute value bars. And you'll see that in this. You saw it in the last unit, you'll see it today as well. The square root of AB, you can separate that. Saw that last time. When it's a quotient, you can take, when you're taking the square root of that, you can take square root of the top and the bottom. And this nth root here just means like cube root, fourth root. So you can do these rules with any root. All right, so we're going to look at combining like terms. So when it comes to combining like terms, an apple plus an apple equals 2 apples. Yep. Just like how 2x plus 3x equals 5x. What you're doing here is you're adding the coefficients together, that's the numbers in front of the variables, and you're keeping the variable exactly the same. So 2x plus 3x equals 5x. You can do the same thing with radicals. So if the numbers are the same here, that's like having x being the same, so they're like terms. So then you would just add the coefficients. So 2 plus 3 would be 5. So 2 square root of 3 plus 3 square root of 3 equals 5 square root of 3. 2x plus 3x equals 5x. Now let's look at these. What do you think 2 square root of 3 plus 3 square root of 7 is? You would just leave it the same because they're unlike terms. Same thing with 2 square root of 3 plus 3 cube root of 3. These are slightly different. One's a square root, the other's a cube root. In order to add like terms, they have to be exactly the same. Either the variable part or the numerical part. So here's an example. Directions state add or subtract. Assume the variables represent positive real numbers, if there are variables. So in order to combine like terms, what you want to do first is you want to simplify it. That looks exactly the same. You want to simplify it. So that means you want to break it apart. You want to find the largest square that goes into 72, which is 36. The largest square that goes into 32 is 16. Square root of 36 is 6, so that comes out. Square root of 16 is 4, that comes out. Now when something comes out, on the outside it's multiplication, right outside the radical, and so you would multiply it. So combine those together, so that would be 6 square root of 2 plus 16 square root of 2. Now we add like terms. Keep the square root of 2 the same. 6 plus 16 is 22. So it's 22 square root of 2. Let's look at the next one. It's like I just rewrote it. Break it apart again. Even though 10, you can break that up as 5 and 2, those aren't squares. So just keep 10 as 10. Now 40, you can break that apart. The largest square that goes into 40 is 4. Now with something like this, you can get a hint on what is being simplified, because in order to do this problem, the numbers have to be the same underneath the radical. So if I didn't know the largest square, what I would try is see how many times does 10 go into 40. And more than likely, it's going to be a square. Sometimes it won't, but most of the time it will. So square root of 4 is 2, and leave square root of 10 underneath the radical. And then 2 square root of 10 plus 3 square root of 10. Square root of 10 is going to be the like term, so you add the numbers in front. 2 plus 3 is 5, so it'd be 5 square root of 10. With part C, we can simplify this. We can also break this apart. 81 is 27 times 3. So with cube roots, you're looking for the largest cube that goes into that number. Then continue to simplify it. So 3 goes into 7 twice, so the remainder of 1. So that would be z squared cube root of 3z plus the cube root of 27 is 3, and the cube root of 7, 3 goes into 7 twice with a remainder of 1. Now combine like terms. Now here it's really complicated what the term is. It's z squared cube root of 3z. And what we're adding together is the 1 and the 3. So that'd be 4z squared cube root of 3z. Let's move to a harder example. So let's look at letter A. So we have the square root of 63 over 3 minus the square root of 7 over 2. Try 7. 63 goes into 7 9 times. Now I can take the square root of each of these. The square root of 9 is 3. And at 7 doesn't simplify, so I would leave that underneath the radical. So I have something like that. Square root of 3, so square root of 9 is 3, so that'd be 3 over 3, which would simplify to 1. I'm going to keep this as 1 so that you can see the coefficient that's in front of it. So now you have, and notice that I wrote it as a fraction. I can do that just as 1/2. 1 minus a half would just be a half. So it'd be 1/2 square root of 3. Sorry, square root of 7. So another way to think about it is if you take $1 and you remove a half or 50 cents, you're left with 50 cents. So you can write it this way, or you can write it as square root of 7 over 2. Means the same thing. So with this one, notice that I can't take the cube root of 9y, but I can take the cube root of 64. The cube root of 64 is 4. Now, since these are fractions and nothing will cancel out nicely here, what I have to do is I have to take this 5, put it over 1, and I have to find a common denominator. Common denominator would be 4. So multiplying the top and the bottom by 4, you get 20 over 4. I'm going to put a 1 here so that you can see the coefficient. So now, since the denominators are the same, I can add the numerators together. So 1 plus 20 is 21. So that would be 21 cube root of 9y over 4. And that's it as far as simplification is concerned. Let's move to radical equations. Radical equations are quite nice, but you do have to check them. So here are the steps. First is you want to isolate the radical. And let me point out the radical. Whether it be a square root, cube root, or whatever, you want to isolate it. So that means you want to get rid of this plus 2, so you subtract 2 from both sides. Then step number 2 is you raise each side of the equation to the nth power to eliminate the nth root. So in other words, you're doing the opposite. The opposite of cube rooting is cubing. The opposite of square rooting is squaring. So after you isolate it, you're going to raise both sides to the third power. If it was a square root, you would square both sides, because whatever you do on one side, you do to the other side. And then step 3 is repeat steps 1 and 2 until radicals are gone. You don't have to worry about that. There might be like one problem where you have to do that, but usually they're pretty simple where you just have one radical. This step is only if you have multiple radicals. So then you would solve the resulting equation, which means that you would either solve by factoring or just solve for x. And then you want to check your solutions. Cube roots, doesn't matter so much. But with square roots, you do, because the square root's domain is restricted. If you recall, the square root of a negative is not a real number. So you don't want those funny numbers. And the domain's restricted, so you want to check your solutions. All right, so let's work out an example. So first we're going to have to isolate the radical. So subtract both sides by 1. I get the cube root of x minus 2 equals 2. Notice that it's isolated, the radical. So now I'm going to cube both sides, raise each side to the third power. What happens there is that this root and this power cancel out. So it's x minus 2. However, on the other side, you're cubing it, so it's 2 raised to the third power, which is 8. 2 times 2, which is 4, times another 2, which is 8. Add 2 to both sides, because now it's just a one variable equation. And I get x equals 10. Now, just to be sure, we're going to check ourselves. So I'm going to check. I'm going to check by plugging in 10 into the original problem. Always the original problem. Some places you might be able to get away with a later part of it, but it's always best to plug it into the original. And a couple weeks ago, I showed you how to, maybe several weeks ago, I don't remember exactly, but I showed you how to do this, how to check on your calculator. So you just be able to plug this in on your calculator, but I'm going to show you how to work it out here. So 10 minus 2 is 8. Remember, following the order of operations, the root kind of acts like a grouping symbol. So you have to do that first. So cube root of 8 is 2. 2 plus 1 equals 3. Check. So 3 would be, so 10, not 3, 10 would be a solution. All right, let's look at another example, and this one's a little bit harder. So, but it's kind of very similar. We're going to isolate the square root, so that means we got to get rid of this plus 4. So really quick, the reason why you wouldn't subtract or combine 16 and 4 is because one's underneath the radical and one is not. So, and the radical acts like a grouping symbol, so it clumps these together, separate from the plus 4. So that's why you want to isolate. That's why you can't do anything with the radical first. So you have to isolate it. So subtract both sides by 4. So we get square root of 16 plus x, x minus 4, square both sides. The square root of a square cancel. X minus 4 squared is x minus 4 times x minus 4. So that means you have to FOIL with this problem. X times x is x squared. X times minus 4 is minus 4x. Minus 4x for the inner. So that would give you, that's where the minus 8x is coming from. Negative 4 times negative 4 is plus 16. So now what you want to do is solve for 0 because we have the x squared there, so that means you have to solve by factoring. So subtract both sides by 16, and you can at the same time subtract both sides by x. I get 0 equals x squared minus 9x. That's coming from negative 8x minus x is minus 9x, and the 16s cancel. So now I factored this. Now, if it's a square, you're not going to always do product sum method or the AC method or splitting the whole term. You always want to look for a GCF first. So here the GCF is x, so I'm going to pull that out. That gives me x parentheses x minus 2. Set each of these equal to 0 and solve for x, and I get x equals 0, x equals 9. Kind of see where that's coming from. Now I got to check both of these. So we got to check when x equals 0 and check when x equals 9. I think that x equals 0 is not going to work because I know this is always a positive or 0 result. Plus 4, that cannot equal 0. But I'm going to plug it in and show you. So wherever there's an x, plug in 0. And like I said in the previous problem that we did, it's best to plug it into the original. So that's what I'm doing. 16 plus 4, 16 plus 0 is 16. Square root of 16 is 4, so 4 plus 4 does not equal 0. That's what happens sometimes with these problems, because that restricted domain, probably more so restricted range, so if I plug in 9, I have 16 plus 9 and then 9 over here. So 16 plus 9 is 25. So that's the square root of 25. Square root of 25 is 5. So 5 plus 4 equals 9. 9 equals 9. That is true. Now we plugged in 9. 0 didn't work, but 9 did. So 9 would be a solution. This 0 right here is what's called extraneous solution, because you get it here, but it doesn't work in the original. All right, so let's review what we did. We went over radical expressions. When it comes to radical expressions, you want to combine like terms. That means you want to simplify the radical first. Once you simplify the radical, then you can see if the terms are the same, and then you would combine like terms. You would add the numbers together, and you would keep the square root the same, or the cube root the same. With radical equations, basically what you want to do is you want to isolate and raise each side to that power. Once you isolate, raise it each side to that power. So if it's like a cube root, raise each side to the third power. If it's a square root, you raise each side to the second power. It's an equation, so whatever you do one side, you have to do to the other side. And then you would solve accordingly. So sometimes you might solve by factoring, and sometimes you're just solving for x.
If you like this video, please like, share, and subscribe. And if you have any questions, put them in the comments below. Thank you, and I hope you have a wonderful week.